Okay, so the next part of section 2 is getting you to really understand radians. Now, the first way that they talk about giving the positive and negative coterminal angles with this is by converting into degrees first. I'm not a big fan of this, but it is a method. So if you were to look at negative 4 pi over 3 and do your dimensional analysis to change into degrees, so put pi in the denominator to cancel those out, 180 degrees into the numerator. Now, if it were up to me, I would simplify, like 3 goes into 180 60 times. So then you just have to do 60 times 4, which is 6 times 4 is 24, so it's 240. So it might help some of you realize that, okay, we're going clockwise, negative 180, bigger than that, but negative 270, that's too much, so we're up here. So then from there, you can, add 360 to that, and you can also subtract 360 from that to get your coterminal in degrees. So this should be 120 degrees. Well, now you also want to convert that back. 180 degrees, pi. Because if you start in radians, you should end in radians. That way you can cancel those out. And you're left with, well, the 10s would cancel. That's what I'm technically doing. 12 over 18 reduces to 2/3. So they're both divisible by 6. So 2 pi over 3. And then the same thing goes with this one. Looking at negative 3. Well, sorry, I forgot to actually add. Negative 240 minus 360. Well, there's two negatives, so you just add them together. Let's see, 40, 50, 60, so 600. And then change it back to radians. So 180 degrees, pi in the numerator. Again, dividing by 10 will reduce there. Divide both of those by 6, and you're looking at negative 10 pi over 3. Now, I wouldn't do things like that. If you think about it this way, instead of adding 360 and subtracting 360, well, what's equivalent to 360 in radians is 2 pi. Well, the problem is they don't have the same denominator, so you need to get the same denominator. Well, what's equivalent to 2 pi with a denominator of 3? It would be 6 pi over 3. So negative 4 pi plus 6 pi would give me 2 pi over 3. You can see that answer matches up. Now, one thing I haven't done yet is drawing in standard position, because I don't know how good people are quite yet with drawing in standard position. If I were you and I was first learning this, I would convert to degrees a lot because most people are familiar with this. When we get into the next unit, just looking at a problem in radians and knowing where it is in the unit circle and which quadrant it's in is pretty vital. But let's finish this real quick. You can also subtract 2 pi to get the negative coterminal angle. So the work is pretty much the same, and that's how you get negative 10 pi over 3. And I'll trust that you can write it in standard position, or I can just share the answer key. I'm totally fine with that. You can see really the same thing. All right. Again, I don't like that he left this answer in degrees. If you start in radians, you should end in radians. That is my professional opinion. So if you need a pause, now's the time as I get back to our notes. The next thing that we're talking about is the reference angle. So that's going to show up pretty big here. And as I mentioned, that is the shortest angle made with the x-axis. That's an acute angle. So you just might need to make practice understanding, okay, so this is 90 degrees, starting at 0, 180, 270. Oh, that's where my angle is going to be. It's a little bit bigger than 270. It's 5 more, actually. So if you think about this being a 90-degree angle, I thought it changed colors. and right here is 5, well then just do 90 minus 5, and we call it theta prime, if you're curious, would be 85 degrees. I did not answer this question though. What quadrant did we end in? That's quadrant 4. Okay, I think we're good with that. Same thing goes with this one. Again, the reference angle needs to be positive and acute. Positive and acute. So important stuff there. So if you think about this one, if you don't like the negative angle, well, you can fix that, you know. Negative 579 and start adding 360 to that. You can go to a calculator, nothing wrong with that. Negative 579 plus 360. I don't like that one, that's still negative. Plus, okay, 141. Now I can work with that. So I'm thinking about, okay, so it had 1 full revolution and then a little bit more. And I'm thinking about 141. It's a little bit smaller than 180. This is my thought process. Like, if I had 141 degrees, which is a coterminal angle, it's bigger than 90 but smaller than 180. So that means that negative 579 has to be somewhere over here. And then you can think about, I guess I didn't really write all my work. And then think about, okay, well, what's the smallest acute angle made with that axis? Well, 180 would get me to that, minus 141. That reference angle would be 39 degrees. And I didn't even answer the other part. What quadrant do we end up in? Quadrant 2. Yeah, so the more practice you get, the easier this will be, trust me. I'm a big fan of leaving this the way this problem is, especially in radians. You'll notice the reference angle is really, really nice as you get more practice. And for a reference is, I know off the top of my head that 12 pi over 6 is a pretty big deal because that's 2 pi. Well, 13 pi over 6 is bigger than 12 pi over 6, so it's at least a full revolution and a little bit more. Now, you will probably need some practice to eventually realize, you know, when does it go beyond the pi over 2? In this case, it would be at 15 pi over 6, because it would reduce down to pi over 2. But it's going to take some practice, some getting used to. So I'm using this to kind of lead you to understand that we end up in quadrant 1. And if you wanted to, you could subtract these, 13 pi over 6 minus 12 pi over 6 to figure out the reference angle. But what's really nice about radians is the reference angle is usually just pi divided by the denominator that you have. I say usually because we kind of get a hiccup on this next one. Because if you look at where negative 3 pi over 5 is, first of all, it's going clockwise. And it's going to end up in quadrant 3. And the problem that we have is that the angle made right here is I have to think about, well, what do I need to add to 3 pi over 5 to get to just pi? And the reason why I'm talking about pi is because that's how I'm going to get to that axis. That would be 5 pi over 5. Well, what do I need to add to that? Then theta prime, that's how we're labeling the reference angle, would be 2 pi over 5. And if you are struggling through this, my first encouragement is to really, really master degrees. And you might just master, and I have had students do this in the past, changing it from degrees, from radians to degrees, finding the reference angle, and then changing it back. You can do that. There's nothing wrong. It's a little time consuming. But if you're struggling with these premises, I know I went through it very quickly, change to degrees, find the reference angle, and then change back to radians. And I'll share the answer key just to kind of give you a... Oh, that's exactly what he does. The answer key changes it to degrees, finds the reference angle, and changes it back. So I'm hitting pause. You should hit pause. I'm going to stop recording, and please bring your questions to class.